Hello viewers, in today's session we are going to discuss another important problem from derivatives, right? And here we are going to solve a problem related to derivatives in which we are going to use the concept of composition of functions, right? So let us first read out this problem. Here we are given three functions: f of x, that is equal to square root of x square plus 2, g of x, x over x square plus 1, and h of x is minus x plus 5, right? And here we have to find the value of this expression, that is f double prime, and here we have h prime of g prime of x, right? So we have to find the second derivative of f of x when the input is h prime of g prime of x, right? So this problem also includes the concept of composition of functions. So let us see how we can solve this problem. So here let us first find out the second derivative of f of x, right? See, here we have f of double prime of h prime of g prime of x. So let us first find the first derivative of f of x. So f prime of x is given by d by dx of square root of x square plus 2, and this expression can be differentiated like this, that is half, then we have square root of x square plus 2, and then by chain rule we have the derivative of x square plus 2, right? So first we have here applied this power rule, that is d by dx of x raised to n is nx n minus 1. So we have x square plus 2 raised to half, and first we have taken half, then x square plus 2 raised to half minus 1, and then by chain rule we'll find the derivative of x square plus 2, right? So when we simplify this expression, we'll get 1 over 2 times square root of x square plus 2. So we have half, this is x square plus 2, and the derivative of x square plus 2 is 2x. 2 and 2 get cancelled, so we are left with x over square root of x square plus 2. So now let us find out the second derivative. So f double prime of x is given by d by dx of x over square root of x square plus 2, and here we'll make use of the quotient rule. If we have two functions, say u and v, and these two functions are functions of x, so we have v du over dx, then we have u dv over dx divided by square of v. So here this function can be taken as u, this function can be taken as v. So we have x, here we have x square plus 2 times we have the derivative of x, then we have x derivative of here we can write d by dx of x square plus 2, and then here we have the square of x square root of x square plus 2. So now we have square root of x square plus 2, because the derivative of x with respect to x is 1, and here we have x, and the derivative of square root of x square plus 2 is given by x over square root of x square plus 2 divided by the square of square root of x square plus 2. So here this the power half is cancelled with this 2, so we have simply x square plus 2, right? So here we can take the LCM, and we can simplify this expression like this, that is f double prime of x is given by, we can multiply these two quantities, so we are left with only x square plus 2, and then we have minus x square divided by square root of x square plus 2 times x square plus 2, right? So now we have this x square and this x square get cancelled. So we are left with 2 over square plus x square plus 2 raised to half plus 1, because here the power is 1 and here the power is half. So half plus 1 is 3 by 2. So here we have 3 by 2. So we have obtained the value of f double prime of x as 2 over x square plus 3 2 divide raised to 3 by 2. So now let us find out the derivative of g of x, that is the g prime of x. So we have g prime of x is equal to d by dx of gx, and gx is given by x over x square plus 1. And here again we can apply the quotient rule. This is u and this is v. So we have x square plus 1, then we have derivative of x, then we have x and derivative of x square plus 1, and divided by x square plus 1 square. So the derivative of x is 1, so we have x square plus 1 times 1 minus x times 2x. The derivative of x square is 2x, derivative of 1 is 0 being a constant, and here we have x square plus 1 square. So this is x square plus 1 minus 2x square. This is x square plus 1 square, and here we can write 1 minus x square over x square plus 1 square, right? So viewers, the derivative of this function g of x is given by this expression, that is 1 minus x square over x square plus 1 whole square. So now let us find out the derivative of the third function, that is h of x is equal to minus x plus 5. So this is a linear function. So h prime of x is given by d by dx of h of x, and this is d by dx of minus x plus 5, and the derivative of x is 1, so we have minus 1, right? And the derivative of 5 is 0 being a constant. So h prime of x is equal to minus 1, and here we can see that h prime of x is a function which is a constant function, right? So h prime of x is equal to minus 1 for all values of x in the given domain, right? So whatever be the value of x in the given domain, h prime of x is always equal to minus 1, and this is the important thing in this problem, because see, we have to find f double prime and h prime of g prime of x. So now if we substitute here g prime of x, then we have 1 minus x square over x square plus 1 square. And now see, here we have h prime of this function. So here our input is now 1 minus x square over x square plus 1 whole square, right? So h prime of x is equal to minus 1. So whatever be the value of x in the given domain, h prime of x is always going to be minus 1. So here if we take this function, as input, then we have h prime of for x we can now write 1 minus x square over x square plus 1 square is equal to minus 1. So for this input, h prime of this function is equal to minus 1, right? So now this expression is now equal to f double prime, and h prime of this function is equal to minus 1. So here we have minus 1, right? So now we have to find the value of f double prime of minus 1. So now f double prime of minus 1 can be obtained by replacing this x by minus 1. So when we take x is equal to minus 1 over here, we'll get the value of f double prime of minus 1, that is equal to 2, divided by we have minus 1 square because x is equal to minus 1, and here we have 2 raised to 3 by 2. So this is 2, and here minus 1 square is 1. So we have 1 plus 2, that is 3. So this is 3 raised to 3 by 2. And we can now write 3 raised to 3 by 2 as 27 raised to 1 over 2. So now the square root of 27 is equal to 3 times square root of 3. So now here we have 2 over 3 times square root of 3. So viewers, the value of this expression when we have these three functions is equal to 2 divided by 3 times square root of 3. So this is how by using all these concepts we can easily solve these kind of problems related to derivatives.